So minutes has passed, so we can start. People can join later, and I think there are always a video. So hi. Today is October 17, 2023. My name is Alexander Jelenek, and this is my Call the Doctor session monthly event. And first of all, if there is anyone who is not member of HDF Group and but has some questions about it, that's usually good to know before I start, so I can optimize the time. Anyone has some questions that you would like to ask about HDF related things? All right. If you see, there is some chat. Okay, chat. So okay, if anyone has them afterwards, always can say, but I can start now talking about what I plan to speak about. So on today's program were actually two things. One, I think this is the one I want to share. Okay. How do I get this thing off my screen so I can see the top?
Hello, everyone.
Hello, Elena. Okay, so my first thing I wanted to cover was what's new in h5py-3.10. This release was done, I think, Monday last week, to be precise. And I think it's kind of interesting and important release. So I'll just briefly cover what has changed. Well, first of all, h5py is now can be used with Python 3.12. That also is very new, the latest one. And the changes are done that now PyPy, who distributes Python wheel binary packages, also comes for Python 3.12. So that's good. I think personally, the most important new thing that has changed is here, basically, that I highlighted down here. And this is h5py was created during the 1.8 era of HDF library, and this is the first release in h5py history that actually cannot be built for HDF 5 1.8 version, because a lot of code in h5py was removed that basically was version protecting for older versions of HDF 5 library. So this h5py 3.10 is the first one that the minimum required HDF 5 library is 1.10.4. And I think that's kind of significant milestone. So anyone, even if you get h5py as a source and you want to build it with some library version 1.8 point something, that's not going to work, I think. Almost pretty certain. The other change that's not mentioned here specifically is that now when h5py is built, it uses the HDF 5 1.10 API macro, which previously, until h5py 3.10, until this release, was that macro was using 1.8 API version. So that's yet another case where probably using using h5py from source, building h5py from source will not work for anything but 1.10.4. Other changes in 3.10 are coming back to new features. Is that now, again, PyPy packages that come for h5py are using HDF 5 library 1.14.12. Oh, sorry, 1.14.2, which is as of right now the latest version. Anyway, there is a little glitch for Mac OS PyPy h5py packages. They're still using HDF 5 1.12.2, and that's, I think, someone back in the day when there were some problems building universal binary packages for h5py on the Mac. There was some kind of a patch that enabled that, but now I don't think that's needed anymore. But that person has not yet removed that patch and done something in the GitHub workflow action to enable 1.14.2 for macOS packages as well. I don't think that's a huge problem. I personally, for a number of years now, I've been installing h5py and HDF library from Conda Forge using Conda or Mamba package managers. But for those who just basically use HDF library through h5py, and that's the only case where they'll get HDF library into their Python environment, then that may be an issue. And I'm hopeful that in coming weeks, someone will fix this as well. The next new feature is the ROS3 or the Read-Only S3 file driver now also supports AWS session token, which is a third component to AWS temporary security credential. And it's a very popular way, especially being popular in the last couple of years, of actually getting temporary credentials to access some kind of S3 resources in AWS. And this is now good that the read-only driver also supports that. And h5py now also supports that as well. And I can show later what is required to use it. Out of other things, as far as the changes, I cannot see the chat or something, so stop me if you want to have some questions. I'm not able to see chat right now, so.
Alexander, I have a question.
Yeah.
I saw sometimes emails on h5py group on our forum when people use parallel MPy or whatever. How those distributions deal with parallel HDF library? Because apparently people are not aware that you need to build HDF5 to support parallel. And I believe the issue that was reported yesterday is just because it's not parallel library or something like this. So how they support it? People have to build themselves or what?
Yes, so that's a good question. I think, well, I noticed that issue this morning when I woke up, the one that you're talking about. Yes, so right now, the way that h5py Python packages are provided on PyPy, they don't use parallel build HDF library. And so if someone just do this kind of pip install way of getting h5py, they're not going to get parallel build HDF library. The one way that, and that's why I switched to Conda or Mamba package managers, is because they provide different versions of HDF library build, and one of them is for MPI. And I think there are also versions for MPitch and Open MPI. I'm not expert in those things, so I'm just throwing names here, maybe getting it wrong. So you can have all these varieties that you can install HDF library. So yes, the documentation for h5py, I don't think it clearly separates and explains this issue. So that's also one reason for confusion.
Maybe they can do something to detect it, so and not puzzle users, because error message was really like, what?
Yes. The error message came straight from the HDF library. Yes, you're right. So there can be some documentation clarification, obviously, which again, as h5py is a community-driven open source project, documentation is usually the easiest way someone can contribute to h5py. So make a pull request and things can happen. So where was I? Yes, any more questions? All right, just stop me. Yes, and there were, this one is actually could be also very important. There was someone who for some time now provided a very fundamental fix for, so the h5py can work with a lot more edge or tricky cases with compound and variable length data types in HDF5. And it's been sitting in h5py PR for some time now, but it's been included in this release 3.10. So people, if they had some problems with compounds, and especially combinations of compounds within compounds with variable length data types and all that kinds of stuff, that's possible in sort of C, C++, and those kind of languages, they may find now that h5py actually works. I don't think that all the possible cases are covered, but I think this fix resolves quite a few problems reported in the past. There was one interesting case here that someone building Debian on 32-bit architecture reported compilation errors, and this was related to H5Z register filter implementation in h5py, and that was fixed also. There was some pointer data type, the wrong pointer data type being used. There was some clarification again here about slicing virtual sources, in other words, virtual data sets. It's another feature of HDF5. There was a fix or maybe removal of a confusing feature that yielded bugs and errors. So that this double slicing is not going to, or multiple slicing is not going to work, like the example here it says. So if this source is actually a virtual data set, previously it was allowed to tack on these slices of slices of slices, but now this is going to raise an error. And oh yeah, so this is that macro that I mentioned here. I can see it now. So now h5py by default uses this 110 compatibility API macro rather than 1.8.
Why is that they're not allowing this slicing? Why they're not allowing this slicing?
I think that, as it says here, it was giving incorrect results. It was not giving actual results of. I don't think it's a HDF5 library issue. It may be. It may very much how h5py decided to expose virtual data sets as a feature, and maybe related to that, because if you want to do this multiple slicing operations, you would have to, the result would have to be another virtual data set object or something like that. And I'm assuming, and this is, I wasn't involved in this. I'm assuming that the result was basically a NumPy array or something like that as a result of the first slicing operation, and therefore you can't do any of that. I'm assuming, but I don't know. Can't talk more because I don't know much about that. So anyway, so that's what's new in 3.10. I'm really excited about this ROS3 security token thing, because usually the communities I work with are very interested in S3 and cloud computing and cloud object store data. And so this was something that was really gaining traction as a very advanced way to enable temporary credentials, because you could use API to get those temporary credentials. You didn't have to log in somewhere and get those things or whatever. It was much better for programmatic data access. And so that's all.
You know, Alexander, I think like the NASA Earth data login, actually they do that exact thing, right? They give you a credential, a token they can use to access the NASA S3 bucket. You don't get, it's not public read, and they don't give you your own credentials, but you get this temporary token you can use. Yes, correct.
So that's that part of my talk or my session. The other one is actually talking about analyzing ROS3, which I said is Read-Only S3 virtual file driver of the HDF5 library, how to analyze those logs. And again, I was doing this, I've been doing this for some time now. And so I just basically turned something that I had on my laptop. And so maybe this could be something interesting to talk about. And one of this called the doctor session, at least give me something to speak about. So from library, HDF5 library 1.14.1, this ROS3 VFD got the ability to log, to standard out a lot of information about its operation. And one of the most important ones when it comes to cloud cloud native data access is how many times one generates an HTTP request for some data. That number of these requests is one of the biggest drivers of performance in cloud native computing, and if not the driver of performance when it comes to I/O. And so I thought this would be something interesting, and I created this simple dashboard, if you want to call it, and I deployed it as a panel. I used panel Python package, and I click here just briefly to talk about it. I'm not going to talk about that. There's another whole story, but this is a very interesting capability where you can, for relatively small amount of code, to generate a pretty powerful interactive is the key here, interactive dashboards or plots, only using Python. And panel is part of the much bigger ecosystem that's called HoloViz, which is also built one on top of another. But as you can see, there is a lot of stuff here. For example, data shader is a very interesting capability where you have a massive amount of data, and it's able to sort of produce these plots that are still significantly reducing the bandwidth needed to visualize the data. And as you are zooming in, it's generating more and almost like a tiling experience, that as you zoom deeper into the data, it generates more refined, more accurate representations of the data. And there are a bunch of other things, but panel, as you can see, is one of that suite of packages. Really, really good, highly recommend. So that's that. And I deployed it as Jupyter Notebook. And I'm hoping I don't have to really go and explain what Jupyter Notebooks are. I think that's pretty much pretty well known by now. And so how to get these ROS3 logs? You have to actually build a library from source. So it's not like easy to get them. I don't think that we really need to get a lot of them. Yes, so right now you have to build a library from source. And because of that, I provided here in this repository 2 examples of these logs. So we can have something, someone can have something. So if you want to try this dashboard, you can go and you can, for example, download this let me open the window. You can now download these logs and use them to upload to the dashboard. How we download? That's a good question. Let me see quickly. Can it run quick? No. I'm assuming if you press, oh, there you go. Download raw file. There you go. So if you click here, you'll get this file down. And I just want to tell, this is how it looks like. These are this log, and these lines here is kind of important. Each one, as you see, people who are familiar with HTTP protocol had is one of those verbs of operations in HTTP protocol, and this represents a request by ROS3 VFD asking for information about S3 object, which in this case is an HDF file, and basically from there the ROS3 VFD extracts this information that says how many bytes the HDF file has, and then onwards each one of the next requests has get. And this is now, for example, another the second request, and there comes the third request, and all the kind of other things. So that's the log content. There's a bunch of other things, and there are much more information that one can enable the ROS3 VFD to export to print. I just needed this for my work. But anyway, this is how you would get a log, and just. You'll see later yet another example of this, but just remember, this is the original, and original means this was from an HDF file that was created, basically how typically people would create HDF file on their local or network or some kind of on-prem file system. So pretty much standard, typical HDF file. And the operations or the task for this log file and for another log file that I uploaded is exactly the same. But the difference is that the other version of HDF file had some things optimized internally, and that's important when it comes to cloud-based access. And so just for information, if you look at this file and you go all the way down, let's see how many. So I can go to the raw version of this file. Maybe it's going to be easier. Yeah. So you, I don't get my line number. Oh, wrong decision. Let me see if I can quickly go all the way down. Anyway, just to tell you, so this whole log file has almost 39,000 lines. And the reason I'm saying that, because if you look at the optimized file, this file for the same data operation, for the same data operation test, has only 43 lines. So as you can see, it's a significant difference. So that's about the logs. Any questions? Again, I can't see the chat, so if you have some questions, just stop me. All right, if not, then good. I will now, the dashboard is basically available on Binder service. And I'm not going to talk about Binder because that's another story. But let's say that Binder is a free service that enables one. And I'm not going to start something now just in case because it needs time. So as I'm talking, I'll see how this goes. So Binder is sort of this free service that allows GitHub repositories to get some kind of a free resource as Jupyter notebooks or Jupyter related web application. And it's been around for some time now. I'd like to say maybe even 5 years. And the idea was that it can create a Docker image out of your repository if you provide enough information in certain configuration files found in your repository. And once this Docker image is available, the Binder then starts a Docker container, and eventually you get essentially a web browser window with something that whatever your repository is supposed to do. Typically, you get a Jupyter Lab or Jupyter Notebook in your browser. In this case, what I clicked on is actually something more because I'm using Panel to create the web app dashboard. So this link here, the right one with the orange color, should launch actually a web app direct. If I click on the left one, then I would get the same web app, but now as a more typical Jupyter notebook. So we'll see if it goes. I've been testing this last 7 or 8 days, and the Binder seems to be oversubscribed like any other free resource on the internet. And so we'll see how it goes. Maybe we'll get to it or not. In the meantime, I prepared a backup on my local laptop if need be. So in the meantime, what is the secret sauce? What Binder service requires? Well, in this case, it just requires this environment YAML file. It recognizes it. It knows that it's part of the Conda package manager configuration, and when it finds it, it essentially runs whatever is in there, installs these packages, and creates the Docker image out of that. And so I basically here specified all the components that are needed to run this. And I basically said I want Python 3.11, I want Panel, and all these other things. I specified the versions because I want to be very specific and avoid any problems with bugs or some newer versions of these things. And basically, out of this configuration file comes the Docker image that Binder then runs. The main part, obviously, the web app is in this notebook. And I can just briefly go through because we are waiting for this thing to be created again. All right. So obviously, you import things that you need to import here. But anyway, here in the second cell, the cell here, is an interesting one. I basically use a fairly new feature in Python that you can have these simple classes called data classes, where a lot of glue code is kind of created by Python itself. I don't have to write a bunch of code. They are trying to replace what in Python is called name tuple as a better way to get that kind of functionality. And I try to play with it. So this class that I decorated with data class decorator basically represents a single get request of raw3 VFD. I just wanted to play with this thing, so I created it like that. So the next cell is a parser of the log file. So this is the function that takes the content of one log file and goes through it and then picks out information that is needed for it. And then as it picks up this information, it generates this byte range class object. I mean, byte range objects out of this class. Oh, I think we are on. Oh no, we're still not. Okay. So it generates this byte range class and creates a list out of it. So at the end, you get a list of all these byte range objects representing each GET request. And then all the rest of the code is essentially for creating the dashboard and providing functionality to the dashboard. This function then looks into this parsed log information, generates the information it needs, generates some of the panel widgets and objects that are going to present the information. For example, here you can see I'm calling a markdown object with some information that's going to be a text. Here, I'm also doing two plots. One plot is here, for example, and the other plot is here, histogram. And then I'm wrapping up all of this to discount panel row widget. So I'm placing these things in a single row. And then I'm creating the whole dashboard and lining up things. And this cell here is basically just a callback. So when you upload the new log file, there will be an update so that is all interactive. You don't have to do anything beyond just uploading the new log file. The whole dashboard will update once you upload the new log file. And let's see if this is ready to go. Well, still working. All right. So any questions here? All right. If not, although I would have loved that Binder sprang to life, it's not going to happen. So I have another option. So I've prepared another option, and I will, as per instructions in the README file, here, I will basically run this dashboard from my command line like that. And it will do exactly the same thing. Okay, still not happening. So this is not a good advertisement for Binder service, but you know, as I said, so I'm going to run this, and you should see in this browser window that I'm sharing with you, I think you should see now this web app. Of course, I have to be in the right directory, but that's okay. Now, there's a little mistakes. All right, let's see now. All right, so hopefully you're seeing. So now basically I'm running a local HTTP server in behind, and it's running, see, it's local host is the URL, but this is how the web app looks like. And I was hoping that we're going to get the same thing from Binder, but it's not happening. So I'll go locally. So this is, see, if you browse, I'm now going to upload one of my, let's say the original ROS3 file. And as soon as I upload it, you're going to now see this. So see, remember when I mentioned text information, when I was going through the notebook, so this is that text information. So for example, here you get like how much bytes was the log file, what's the file size of the HDF file. Here's the important one for people who really want to analyze ROS3 logs. The number of S3 data read requests. And as you can see, 6,000, almost 6,500 requests. That's the red flag. That's the killer thing in cloud native computing. You just cannot have this many requests unless you're really using data to that much. But for this task, which was much simpler, this is just a bad thing. And as you can see, some of the requests were as little as 6 bytes. The largest request was just under 40 kilobytes. These are all indicators of very bad cloud native performance. This is the maximum byte that was reached in the file. when the data was read. This is the total amount of bytes that was read from the file, and this is the percentage of the bytes read compared to the entire file. So for the 0.31% of the file, there was almost 6,500 read requests. So that's a huge problem. And this histogram is just represents the distribution of these requests and their byte size. And as you can see, there's a lot of these requests that are very close. And the good thing about this panel, and I said this, mentioned this whole of views, that this is all very interactive. So you can, for example, you see I can now basically move around. I can do whatever I want with this graph. All is live, and I even have this hover tool that I can look into this and get information about the data and all that stuff. So that's a histogram. The other one, the bottom down here, is actually trying to plot each of these requests on the x-axis in the sequential order that they were made, with the y-axis representing the starting file byte of these requests. And as you can see, all these things that look like a dust on your screen, it's not the dust. These are actually valid requests by the library. For example, you can hover and you can actually see that there is even more than just one here. And you can see the request number in sequential order. You get the start byte in the file, you get the end byte, and then the next one, and the next one, and the next one. And because this is this live display, you can still going. Oh, we had one. All right, sorry, jumping. I'm just curious. So you can zoom in now. For example, let's zoom in just to here and just show you that this is. So for example, here, and then you can see, oh, these little dots. Well, let's go a little further to them, and then we see, oh, there you go, and then say, okay, how many bytes are we talking about here? And this is, as you can see, it's basically 295 bytes or something like that. 96 actually. So anyway, so that's basically the ability. I know this is for show, but I found it interesting to look at these things. So this is for the original log. Now for the optimized log, or in other words, a copy with HDF file where we did some optimization. And then you can see a tremendous change. See how first the information immediately updated when I uploaded the new log file. You can see now we're talking about just over 1,000 bytes in the log file. The number of requests is only 5. There are some still issues with making smaller requests by Read-Only VFD. We are hopefully going to address them. But here is the one that really matters. There was 8 MB request.
I can probably look into that frame that good. There's a big folder there. I probably look into that. Part of the
I can't hear well. I couldn't understand.
that other one has.
But anyway, so that's basically and again you can hover around these things, and you can see now the graph is much simpler. You have only 5 requests at the bottom, and there is one really big one that dominates. There are some more interesting plots if you're into looking into these plots. This one, and I'm going to go further up from my computer. This one is I find it interesting. This is for the same version of the file, but where you have enabled, where you have a single metadata block size of 8 MB. And that changes how some data in the file is organized. I'm not going to go into that too much for this session, but it makes a really interesting graph. Now, all these requests that before were scattered all over the file now actually happen within almost 8 MB. The first 8 MB of the file, as you can see, you can now see them very well in the single plot. And as you can see, there are all kinds of things here that look like, as I said, dust on your screen, but no, these are actually plot requests. And if I zoom in here, You can see them. You see how they're tiny and go like it. You know, for geeks, it's interesting to look at these things. So that's basically that.
Alexander,
Yes.
this is actually great. We needed this tool for a long time, and not only for S3 VFD, but for other VFDs too. There is already instrumented MPI-IO driver, and Scott will remember the variable that you have to turn on to get log files. I believe Larry was working on instrumenting SEC2 driver to kind of also get this log information. So if it can be extended, it will be huge help and essentially looking at this, understanding why we have small requests when there shouldn't be small requests, you know, and what recommendations can be given. It will greatly help to improve performance for the users.
Yeah, I mean, obviously, and as I say,
yeah,
go ahead.
yes, if it can be unified and used with any driver, this will be, it's a great tool. Thank you.
Sure. And as I said, I mean, it helped me a lot to understand what I needed to understand of the library behavior, especially when it comes to cloud native data access. And so, but yeah, besides these nice graphs that look almost like some kind of a, you know, how they call them? Yeah, I forgot the name now. Escapes my head, but okay, I'll probably remember. But anyway, so that's how you can use it. You look into these things, you get through some kind of steps, and obviously you can extend it and do whatever you want with it. And if you ever want to get back to the original one, you can just go reset and you get to the original view. And if you don't want to get this too much information here, you can turn it off, and then you don't get this cover information. If you want just to move the graph, you can always move it. And it's very, very useful. Very good for data exploration. And is Binder finally done? No, it's not. So good that I had the backup plan. So anyway, that's that. Unless someone has some questions, that's pretty much everything for today. I don't see the chat, so please, if someone wants to ask something.
Alexander.
Yeah.
Is there a CAPI into the logger?
No.
Okay, so
No.
so the only way to get at it is to parse the text files.
Correct. Yeah.
Okay.
So you go into the library C code, you change the line. I actually said what line you need to change. Basically, you have to do, there is this file in the library source code. You need to find this line, and then you need to change 0 to 1. And then you rebuild the library. And at that point, if you use RAW3, obviously VFD, you're going to see on standard out to see this information that's basically captured in this log file. And if you redirect that to a file, that's how you get it. I don't think you need to run this too much. I think you can get pretty much very quickly information, especially from, as I said, in cloud computing, things are very simple when it comes to optimized access. You just make only one request, if possible. If not one, make two. If not two, make three, but definitely don't make thousands. Unless really this is for some kind of data, obvious. But even if it's for some kind of data, really, really try to avoid making a lot of requests. And so you can very quickly kind of figure out you know, what needs to happen here. So I'm not really concerned that you have to build a library to get these logs. I think you could just have to do it once and figure out for your file. And here, obviously, in this paragraph, I'm kind of explaining what kind of allele I'm hinting to some kind of optimization that will apply to this file. But as I said, it's a little bit bigger topic, so I didn't want to burden this little repository with that kind of stuff.
Yes.
Is Binder? Well, no. Well, that's really
okay. Well, I wonder if as Elena said, if the logging is generalized to a number of the VFDs, it might be nice, as you say, it's not terribly sophisticated to get a sense of what's going on. But if you had a CAPI, a mini API that sort of gave you some sense of it, it could be built into an application on the C side, just to get some sanity checking on your cloud usage. That's where I was just going with the API into the logging service.
Yeah. So I just remembered now. Actually, this is actually a talk I gave in July on some conference. I can drop it into the chat. That talks much more about how to cloud optimize HDF files with more specifics. And I used one of these techniques that I talked about here. I'll drop it in the chat for people who might find it maybe interesting or not. But yeah, that's that. Okay. Any questions?
Alexander, I have one more. This has to do with the first part of your talk.
Yeah.
There was the pull request for the nasty bug fixes on nested compound types. Do you have any, can you comment on the degree to which the Python community uses nested compound types, the depth, and how sophisticated do they get? Is it compounds of arrays or arrays of compounds? Is there any, do you have any sense of how sophisticated they get in terms of the types of things they want to do with compound types?
Only somewhat. Obviously, HDF5 is everywhere, and so and the general community of HDF5 users is very imaginative. So there is no limit on how they can imagine those data types, especially those composite data types. What was this?
Yeah, that was 2134. It's your first bullet item.
Yeah. So that's the one. So there was a bunch of issues here that he tried to basically solve. How much? Well, depends who created the data. So if someone is using h5py to actually create HDF5 files, then obviously those files, even with compound data types, will work, because you cannot. H5py does not really support everything that a C or C++ application would be able to create in terms of composite data types. So if the files are created by h5py, then obviously that will work. Typical problem comes when someone has some C++ and then wants to use h5py to read the data from. And then depending what I've seen cases are typically when you have a compound, and then inside the compound is another compound somewhere, and then that compound has an array data type in one of the fields, or some field around that compound has a variable length data type. Those kind of cases. Then it becomes very, very complicated, because as I mentioned many times before, h5py really is sort of a byte converter between the HDF5 library and the NumPy objects in memory. And so to the extent that it can find the applicable case in NumPy side, that can probably do some work. But if that is complicated, then that's where things stop. And this person actually really did an excellent job. He chased down a bunch of things on that lowest level when those bytes be basically transformed coming out of the library into NumPy. And I'm expecting that this opens up more. But which cases, like for example, let's see this one. This is one of the issues, and if someone included description of it, but sometimes they don't. I'm just looking here if people actually are giving dumps h5 out. I'm not sure if that's the case. No, that's not the case. Yeah, well, I'm not sure that I found a good case like this, but let's say maybe this one. Yeah, there you go. Issue reading h5 with strings is a compound inside VLAN. So There you go. So this person gave a dump. So you can see now you have a compound. Then you have a one field is a string, a variable length string. Then comes some numbers, which is okay. Then a VLN of unsigned integers. Then a bunch of typical things. Then comes a VLN of compound, which is a variable string. And then another string within that compound inside the VLN. So it's a VLN of compound with two variable length string fields. So those kind of things gets really kind of crazy. And that was the problem. So this fixes those kind of issues.
I see. Thank you. Excellent. Thank you.
Yeah. Anyway, more questions? Let's see if Binder finally came to something. Oh no, this is really bad. Anyway, luckily that I could run this on my computer. All right, so questions?
No.
All right then. Well, thanks for attending. Hopefully this was fun or interesting. You can obviously fork this dashboard. I'm interested in pull requests to enhance it in any way, but other than that, it'll stay around for a while, and maybe it will grow into something more useful and more general. So thanks.